Okay, so these questions become more common. We've got a mixture of ratios and percentages. Sometimes they bring in other things as well, but this is what they're going with. So in a shop, the ratio of male to female staff is 2 to 3. You've got 20% of the male staff being under 20 years old and 40% of females being under 20. What percentage of all people in the company are age of 20? So what I have to do is to be able to get some percentages from here, really, because if the answer is going to be into percentages, I need to get everything into percentages. So at the moment, I know that 2 to 3 gives me the fractions of 2/5 and 3/5. Okay, so 2/5 is 40%, because 1/5 is 20%, and 3/5 is 60%, which makes sense because they both make 100% of the company. So it's saying, these are the males, remember, these are the females, that 20% of this amount of people, so 20% of 40%, sounds a bit weird, and 40% of 60% are aged under 20. So to find 20% of this, you know, that 10% is 4, 20% is 8, so 8% of the males under 20. 40%, you can do it any way you want really. 10% is 6, so 40% is 4 lots of that, so it's 24. So 24% of the females are under 20. So in the end, to find the total percentage that are under 20 years old, you can add them up. So 32% of the staff are under 20 years old. Okay, so that's how that one goes. A new member of staff joins the shop. Karen is a 35-year-old female. Explain whether or not it will change your answer in part A. Okay, it will change it. Okay, because obviously these are out of a certain total. The percentage is including more, so it will change the answer. It will reduce. It will give it a slight reduction. Okay, because there's a low proportion aged under 20. So basically, there is more females now older than 20%, older than the 20 years old. So the proportion of these people, the 24%, will actually go down. Okay, so it will make an effect. The proportion of females under 20 will go down. So there's more older females, so the proportion of younger females has gone down. Okay, so it does have an effect. Awkward question. Okay, so next bit. Now we haven't seen a lot of these in the practice papers at all, but they are very doable. It's just about how you can visualise things in your head, and if you're not very good with visualising, watching the MathsWatch clip will help. So plans and elevations is nice and straightforward. It's just about imagining, drawing things from different perspectives. So on the grid, draw an elevation in direction of A. So draw this as if you were stood at A and you were looking at the building this way. So you won't see all the 3D effects, you just see like the outline of whatever you could see from this way on. So what you got to do is look at how wide this is. So at the base it's going to be 3 wide, because you can see that there, because you've got two squares coming in here, and then the next one would be 3 wide. The front bit, you'd see this building bit here, you'd see that line here, and you'd see the edge there. So you'd see the edge there, you'd see that bit there, and you'd see that bit there. Okay, and then a line, because there's like a platform there. Then you wouldn't see anything else above here, there's empty space here, but at the back you'd see this little tower coming up. So you'd see this tower coming up here, like that. Okay, so that's how it would look from that perspective. Okay, like an L shape. Okay, and the lines are important because it shows where the edges of these parts are. Okay. Next bit, direction B, so looking on the bird's eye view. Okay, so just imagine what you can see. So you'd see all this bit here. So if I actually highlight it, it's probably better. You'd see all this.
Is there any staff available to go to the top floor, please?
You'd see that. You'd see this, and you'd see this bit. Okay, that's what you'd see. I mean, to be honest, I could have done the other part of the question that way. I could have shaded in that from the perspective of A. That's what I was seeing. Okay, I'm going to see all this pink bit, including that black square. So I'm going to have going here. It's going to come along 2, out 2. It's going to come in 1 for this bit, down and across. It's got this weird shape. Okay, so what we've got that bit going to 2. It's coming. Oh, sorry. It's coming down. So that's me drawing this bit here. Look, I've come across up to here, and I've come across up to here, and I've come in now, and I've come back down. So this is what it will look like. Okay, so that's the bird's eye view, and this is the black square. So I'm going to shade that in. Not a beautiful picture. You should be using rules and so on. Okay, it's difficult to describe kind of when you're trying to sort of show your pen and stuff. It'd be better if we had a visual shape to show you kind of what you're looking at. But this shading idea will reveal kind of the shapes you got. So the shading idea, you could see this sort of like zigzag effect. From this perspective, you could see this bit, and that bit to draw for this part here. Okay, they're plans and elevations. They are nice and straightforward. It seems like I did a bad job explaining that one. Right, okay. There are not. Show the question. There are 900 students in a school or at a school. Joe is organising a party. He's going to order packets of crisps. He takes a sample of 30 students at the school. He asks them which flavour they want, and he's got the table results below. Work out how much packets of cheese and onion crisps Joe should order. Write down any assumptions you make and explain how this could affect your answer. So he's done a small sample of people. Okay, just like when we asked you guys kind of what you want for breakfast or whatever before the exams. We've taken a sample of 30 people, and this is what we've got. So this is for 30 people. Okay, if we wanted to upscale that to 900 people, you'd need to figure out what relationship there is between 30 and 90. Okay, so how would you get from there to there? So to turn a 3 into a 9, add times by 3, and to make the 30, that would make 90 for times by 3. To make 900, it's 30 times bigger. So the sample is a 30th of the real thing. Okay, so if I times these by 30, all these, I'll get kind of an estimation of how many packets of each flavour I'd need. So 3 times 4 is 12, so 12, add a 0. 3 times 7 is 21, add a 0. 3 times 9 is 27, add a 0. So the sample was 30 times smaller than the actual thing, the actual amount of people that needed, so I'd do 30 times more than that, and that would give me 900 people. The assumptions that we've made for this is that everybody was asked randomly. Okay, so the sample was selected at random. Okay, and it assumes that everybody is going to come to the party as well. Okay. So everyone's coming to the party. Okay. There's another thing to mention, that the sample is small, so it's a small sample. Small samples give inaccurate estimations, so a small sample gives rough estimations. But the answer was, how many cheese and onion crisps do you have? So cheese and onion was actually 270. It's 270 cheese and onion. Okay, so that bit's quite straightforward. This bit here is just understanding kind of what affects an estimation when you're using a sample.